years, it hasn't been until the last 30 that the technology of telescopes came into sharper focus where you could actually carry out this exercise. So starting with 1995, okay, now to be clear, this is after Nirvana broke up, but before Britney Spears made it big, okay, so that's give you a scale, okay? So during that, that decade, right, we found the first planet orbiting a sun-like star. And since then, right, we have experienced an explosion of this activity, right? This diagram here shows you all of the planets that we have discovered to date. We have approximately 5,000 of them now in the galactic planetary census. And looking at this diagram alone, ignoring this text, which is typeset at 0.1 font for your readability, you note that there's the whole spectrum of planetary objects. There's big ones with rings, there's kind of smaller, kind of Neptune-sized things, there's a bunch of rocky-looking worlds. So you have the full spectrum of planetary system. But just like that picture of the solar system, which didn't show you the orbits to scale, this picture is misleading, okay? Because it doesn't show you where the orbits are. So let's take a look at that again. Okay, so this is projecting all the planets that we found to date around their host star. Of course, they don't all orbit the same star, right? They all orbit their own individual stars, but putting them all in orbit of a single object for just visualization, this is what the currently known galactic planetary census looks like. And if you're a careful observer, you might be like, that star looks really big, right? I'm sure it looks big compared to the planets. It's the same question as like, are children small or are they just far away? Right? No, they're small. So this is the staggering thing that we found out. Okay? This is the galactic planetary census. All the planets we know of today. This is the orbit of Mercury, the closest thing we have to the sun in the solar system. Okay? Venus, Earth, and so on. Right? We're not the average outcome, clearly. Most of the things we found to date complete a single revolution around their host stars in a matter of days. The kind of outliers over here, for them a year lasts a whole couple weeks. But most of them just orbit their stars in a matter of days. And it's just a staggering, it's just a staggering discovery, right? What does this mean? This means that all of our understanding of how planetary systems emerge, which has for the last 100 years been constructed to reproduce the solar system, is just plain wrong, okay? Because the solar system, as it turns out, is kind of maybe a little bit weird. This is the standard outcome of the planet formation process throughout the galaxy. Okay? So, again, just without being a phenomenal statistician, you can kind of just look at the kind of objects that orbit their host stars, and you can find that there's big ones and small ones. And a little while ago, my friend Andrew Howard, who's a professor of astronomy at Caltech, and him and I were hanging out, and he asked me, he's like, okay, if you were to construct a planetary system out of the census of the planets we've discovered, what would you see? And I said, well, I don't know, you'd see some big guys, you'd see some small guys, they'd all be pretty close to the host star. And he said, wrong. Here's what he found. Okay? He said, yes, if you take all of the discoveries that we've made today, put them in a bag, and start drawing randomly, you would get great diversity. But if you examine each planetary system in isolation, what you see is extraordinary intrasystem uniformity. So there's something about the planet formation process that creates a great variety of planets. But once the particular star chooses what kind of planet it's going to create, it's like a factory. We'll stamp one after another of the same type of object. both in terms of planetary spacing, in terms of mass, in terms of radius. So this is yet another discovery that adds a moment of true confusion, because this is so different from the solar system itself, right? As we discussed in the first slide, right, the solar system has a vast variety of objects. So what's going on here? And so inspired by that conversation, I thought about it quite a bit, and I thought, okay, there's somewhere we've seen this kind of thing before. Okay, like this is eerily reminiscent of another thing that we know of in astronomy. And in fact, this is eerily reminiscent of literally the first discovery ever made in astronomy. Okay, and that is the discovery of Galileo Galilei when he adopted the telescope as a scientific instrument in 1609 and looked up at the night sky. Right, he first looked at the moon, but okay, we don't need a telescope to know the moon is there, hopefully, right? And then he looked at the other thing that's bright. He looked at the brightest thing out there, which was Jupiter, and then he drew this. And I want to draw your attention now to the fact that Jupiter itself is encircled by 4 other stars. It's very weird that Galileo's drawings are so pixelated, but it's the kind of technology. Yeah, he didn't have Microsoft PowerPoint. So what are these? These are the Galilean moons. Okay, the moons that encircle the planet Jupiter. What's interesting about them? Well, first and foremost, these objects orbit Jupiter in a matter of days, just like extrasolar planets. Secondly, if you were to take them, okay, and take Jupiter itself, as well as its satellites, and blow them up such that Jupiter becomes a mass of the sun, and you were to ask what kind of planets would these become, they would be the typical extrasolar planet, a few times more massive than the Earth, and yet a few times less massive than Uranus and Neptune. So even though the solar system itself seems a little bit weird, the satellite system of Jupiter, right, looks like a miniaturized outcome of the standard outcome of planet formation throughout the galaxy. Okay? So inspired by this, we decided to look into this problem more closely. Now, both planets and satellites do not just appear in isolation, right? They appear during the first few million years of the lifetime of a star, when stars are encircled by these thick disks of hydrogen and helium gas, as well as dust. And this is not a picture from 4.5 billion years ago. This is an artist's rendition from one of our models, but the young Jupiter would have looked something like this, where it was encircled by this cloud of hydrogen and helium gas, which also had a substantial dust